Good morning, everyone. So today we're just going to do a nice little review, going through some information before I give you a little assignment to practice. So without further ado, just as a reminder, we are reviewing topic 2, and that was multiple representations in the real world. We'll just abbreviate that and say multiple reps. Okay. So if you remember, a lot of this section dealt with Mr. Chang and his son Anthony, and they were going through and building pool models and trying to figure out the number of tiles to go around. Okay. So with that, there was 4 different ways that in math we represent things to analyze different problems. Okay. So what we did is we took one specific problem and we showed you 4 different ways. Okay. So of these, the first way to represent a problem is through concrete representation. Okay. Concrete representation. And what that is, guys, that's a fancy way of saying a model. Okay. A model. So with that, in this example of Anthony, we had a pool that we tiled. So say it was a 2x2 pool. We had where we said that there was, let me use my different color pens here so we can see it. So our 4 tiles were our pool. Okay. And then around it, we had our other tiles. Okay. Another way that I can show breaking this apart, again, if we do our 4 tiles, and again, I'll put those blues so you could tell that that was a pool. Another way that those tiles could be broken apart is if we did 3 here, 3 on this side, 3 on that side, and 3 on this side. So again, if we show that, they're all connected the same way. But what I did is I just showed you how we compared it. So here we just counted them all up. Here I broke them into 3s on each side. And there's actually another way we can do this. We could break this. So again, here's my 4 original. Okay. And we can look at 2 tiles on this side, 2 tiles on this side, 2 here, and 2 here. And then we can think about the 4 in each corner. Personally, that's how I always think of it. There is no right or wrong way to think of this, guys. However you want to see the pattern, you see the pattern. Okay. So then our next way that we can look at these things is through a symbolic, what we call a symbolic relationship. And that is just a fancy way of saying an equation. Okay. So on this particular problem, we had different ways that we could come up with which one of these models matched an equation. So just to help you guys see this, and again, you're going to go with whichever one that you see. So with this one, what I like is the 4. One of my favorite is just are the 4 sides, four sides of tiles being multiplied the length of the side plus 1. So the length of the side is 2 plus 1 is 3. So 3 tiles times 4 sides. So that's one of my favorite ones. So there I'm going to go ahead and pair that together. Okay. Now, another way that we can think about this is up top here, we've got are 4 sides. So 4 times the length of the side. So S is 2. So 4 times 2 plus my 4 corners. So that one's going to go here. And lastly, this is going to equal the same thing, but I don't even want to try to explain how they came up with this equation to match this this concrete model. But what that is going to be T equals a side plus 2 squared minus side squared. What you guys do need to know that all 3 of these equal one another. That one equals that one equals that one. It's just a different way that we can write them. Okay. The third way to represent these situations is what we call a numerical representation. Okay. A numerical. And that, again, is a fancy way of saying a table. Okay. So again, going with this model, my example of that was we had the length in feet. We had the tiles in the border. Okay. And we went through and we said, if the pool was 1 foot wide, there was a total of 8 tiles in the border. If the pool was 2 feet wide, there was 12 tiles in the border. If the pool was 3 feet wide, there was 16 total tiles. And we could plug in any number to the side, whether we want to plug in 4, 5, 6, 7, 8, and we can use the equation 4 times S plus 4, that came from up here, to give us that answer. Okay. And now lastly, the last way that we can model a situation is by graphical, which this one's not hard to figure out. Graphical is a graph. A lot of times what we do is we take a table, a numerical representation, and turn it into a graphical. So here I'm going to show you, we've got a graph where we said the pool length in feet. And we'll call it 1, 2, 3, 4, 5. And we've got the tiles on this side, the number of tiles. And we're going to call this 2, 4, 6, 8, 10, 12, 14. Okay. And we can go back up to our table here. And we said when there's one, let me switch pen colors so you can see this. When there is 1 foot of length, there's going to be 8 tiles in the border. When there's 2 feet of length, there's going to be 12 tiles in the border. When there is 3, there's going to be 16. So we can see that the pattern that this is taking is actually a straight line. Okay. Now, something I want to talk about with this graph right here. Okay. Graphs are going to show us 2 things. Okay. The first thing this graph shows us, and I'm going to color code this for you to see. In blue, the first thing that this graph shows us are the discrete points. The discrete points that are actually in our table. Discrete points of our specific problem. Okay. And then you guys can see my line here that I drew for you. Okay. What this actually showed us was the continuous model, as if this was a mathematical function. Okay. So those are the big things that you guys need to get out of this. Now, here's the thing. You will need to work on how we take our tables and come up with the symbolics. That's probably our hardest part right there, is understanding that. So the next thing that you guys are going to do is you're going to work on some of those specific problems. So make sure you check Canvas for what your next assignment is. Bye.